Hi, it's Mrs. Pope, and today we're going to be talking about radical expressions. This is part one of two-part video. Our goal today is to add, subtract, multiply, and simplify radical expressions. Sounds like a lot, but it's not that bad. We're going to start with the key concept, product property of radicals. So the product property states the nth root of a times b is equal to the nth root of a times the nth root of b. So these are letters. Let's put some numbers with this so you can see what they mean. So for example, if I had the nth, that means if it's just a square root, we don't really put the little square here, but that's really what it means. Square root, just like if it's a cube root, we'd put a 3, a fourth root, we'd put a 4. But if you don't see one, we just understand it's a square root. But that's really there. So if we had the square root of 16, if you recognize 16 is also a factor of two things multiplied together. So the square root of 16 could also be the square root of 4 times the square root of 4. So the nth root of something multiplied together is the same thing as if you break them apart. Square root of 4, of course, is 2. Square root of 4 is 2. So 2 times 2 is 4. Now, of course, we all know the square root of 16 is 4, but this just shows you how this property works. It can also go the other way. You could have the cube root of 3 times the cube root of 9. There is no perfect cube of 3, there's no perfect cube of 9, but if I put them together using this property, I would have the cube root of 9 times 3, which will be 27. And there actually is a cube root of 27. It happens to be 3. So you'll have to play around. When we're simplifying these, you need to play around with them to make them work for you. So let's see how we can do that. Okay, example 1. We want to simplify the square root of x to the 8th. So first we look at 32. It's not a perfect square, so I can't simplify it right away. So my hint is to try to find factors of 32 that are perfect squares. So you want to break 32 down into its factors. One that would be a perfect square, so you can pull it out. So I could take this and make it square root of 16 times 2 times x to the 8th. Now why did I do that? Because the square root of 16 is a perfect square, so I can pull that out. So this really becomes square root of 16 times square root of 2 times square root of x to the 8th, using our property. Well, of course, square root of 16 is just 4. Radical 2, there's nothing I can do there. And let's talk about what we can do with this x to the 8th. So I can't take the perfect square of x to the 8th. It would have to be x squared in order to take its square root. But what I can do is, it's a little trick. Remember I told you that this is really, the index is 2. So the trick is you can take the exponent, divide it by the 2. I know it sounds crazy, but this turns into x to the 8 over 2. And we will look at this property a little bit later, but this is what you actually do to make it work. So then we have, that's going to be, of course, to the 4th power, 4x to the 4th radical 2. So that's how we simplify them. Let's look at the 4th root of 16x to the 24th, y to the 13th. And after another example, you may be able to understand this a little better. First, we're going to break it down. This really is the 4th root of 16 times 4th root of x to the 24 times the 4th root of y to the 13. So we're going to try to break these down and see what we can do. Well, the 4th root of 16 is actually just 2, because 2 times 2 times 2 times 2 would be 16. And then remember, we're going to turn this to x to the 24 over 4, because that's a 4th root. And then let's look here at the 4th root of y to the 13th. Now I'm not going to take y to the 13th.
Please report to the main office. Jasmine Jones, please report to the main office.
That's what we have to deal with when you're in school. We're not going to take the 13 divided by 4 because we're not going to get an even number. So we need to do a little trick. Let's turn y to the 13th into the y to the 1, y to the 12. That's still y to the 13th, but now I can take this one, divide it by 4, and get an even number. So here we have 2x to the 6th, 4th root of y to the 1 times 4th root of y to the 12. Well, that's going to stay the same, 2x to the 6th times the 4th root of y. And remember, this is going to turn into y to the 12 over 4, which would be y cubed. So final answer, 2x to the 6th y cubed times the 4th root of y. And you'll traditionally see all of the coefficients, variables, everything before the radical. Usually you see that written in the radical at the end. All right, let's see what else we can do. Example 3. Now we're going to multiply radicals. So we want to multiply, this says 5 times the cube root of this times 3 times the cube root of this. So we're going to multiply these together. We're going to put them all together. So the first thing we're going to do is multiply the 5 and the 3. So we have 15. And then, since these are cube root, they're both cube roots, make a big old cube root sign, and we're going to put everything together. So negative 12 times the 18. And then we have a times a squared. That's this one and this one. Then we have b to the 4th times b squared. So let's put all this together and simplify. So negative 12 times 18. We have negative 216. A, remember that's like a to the 1st. We have a cubed and b to the 6th. So now let's break it down and take the cube roots of each one of these. Oh, and don't forget, times 15. So the cube root, 15 times cube root of negative 216 times cube root of a cubed times cube root of b to the 6th. B to the 6th. So I just broke down each one under the radical, just what the property tells us. So the cube root of negative 216 is negative 6. Don't forget we have to multiply by 15. Cube root of a cubed, well, they're going to cancel each other out, so that's just going to be a. And the cube root of b to the 6th, do you know it? Should be 6 divided by 3, which would be 2. So this turns into b squared. So 15 times negative 6 is negative 90 ab squared. All right? 2 more examples. Subtracting radicals. So when you're adding or subtracting, you need to make sure you have like terms. I'm going to call them funny looking things. So whatever is under your radical, it needs to be exactly the same, and the index needs to be the same. So here I have the square root of 98 minus 2 radical 32. I can't do anything right now. I don't have any like terms, but I can change them so that they do have like terms. So let's break down. Let's first look for some perfect squares and see if we can break these down any easier. So here I would break 98 down into 49 times 2. Why did I choose that? Because 49 is a perfect square. Minus 2 times, let's break down 32, look for its factors that are perfect squares. We did this one already, 16 times 2. So now let's see if that gets us anywhere. Here I'm going to have square root of 49 times square root of 2 minus 2 times square root of 16 times square root of 2. Square root of 49 is just 7 radical 2 minus 2 times square root of 16 is just 4 radical 2. So I have 7 radical 2 minus 8 radical 2. Now here's my funny looking things, the like terms. Radical 2 is a funny looking thing. Radical 2 is a funny looking thing. Your radicals need to be the same. So you have 7 of these funny looking things minus 8 of these funny looking things. That's going to leave you negative 1 of these funny looking things. So it's just you almost think of them like a variable. All right. One more example like this one. We're going to add now. So adding, we still need to have it's like terms. So we have 5, none of these are alike, so let's change them to make them alike. So remember, let's look for perfect squares. So 5 times square root of 4 times 3 plus 2 times, I guess I could use 9 and 3, minus square root of 64 times 2. I picked out factors that were perfect squares. So that way this turns into 5 radical 4 radical 3 plus 2 radical 9 radical 3 minus square root of 64 square root of 2. 5 times 2 times radical 3 plus 2 times 3 radical 3 minus 8 radical 2. Now let's combine these all together. 5 times 2, 10 radical 3. 2 times 3, 6 radical 3. And minus 8 radical 2. So now let's look for our funny looking things or our like terms. Here we have radical 3 and radical 3. We can combine these, but we cannot combine it with radical 2. That's a different funny looking thing. So our only two like terms are the radical 3. 10 plus 6 would be 16 radical 3, and we still have to subtract our 8 radical 2. So this would be our final answer. Thanks for watching, and remember, you are responsible for your own learning.